CloudOps for Red Teamers. In case anyone's wondering who I am John Ventura. Back in the day, I was part of ISS X-Force, the original X-Force. Since then, I've worked for a number of software service providers, platform as a service providers. I've done some work in cloud computing. There's been some lessons learned. A lot of that's been learned the hard way. Hopefully today, you'll be learning it the easy way. Along the way, I've also published some work publicly. Some people call that security research. So if you want to see I'm a security researcher, I'm not going to disagree with that. Also, because this talk is how the sausage is really made, if you want to say I'm the sausage king of Chicago, I'm not going to disagree with that either. All right, so this is what we're doing today. Today, we are going to learn by building infrastructure. Security's huge. It's holistic. It touches a lot of different areas of computing, maybe all the different areas of computing. And how do you learn it? How do you stay fresh? We're always learning. I think one of the better ways to do that is through development. Build something, code something. Choose a project that's maybe a little bit beyond what you're currently able to do, because you're gonna have stumbling blocks. You're gonna have hurdles that are hard to get to jump over. That's okay, because the people who are building the systems that you're going to be assessing or breaking into, they face those same stumbling blocks that you're facing along the way, and that's where the vulnerabilities lie. So if you want to get better at security, development is absolutely a really valid path towards that, and we'll be exploring that today. Of course, development is not the only way to learn security. A lot of people like CTFs, capture the flag exercises, but what happens if you go beyond that? Maybe you want to host a CTF for all your friends. Well, you're going to need a stable, secure environment to do that, and we're going to be discussing some of the tools and techniques that will enable you to do that. Also, if you're on a red team, you will need a controlled environment to test from. You'll see how to build that too, or maybe you want an environment to test out the new exploits, the new techniques, and you will learn proper ways to do that. I know a lot of people here, you've got those ideas for startups, and maybe you've got, maybe you want to do the, Uber for firewall rules. Well, you're going to need a back end for that. So if you got that great startup idea, it's not necessarily security related or whatever, but you're in the right place. So how are we going to? So how are we going to build that? Well, I'm going to tell you how we're not going to build that. Today we're having a funeral for the mouse, okay? All of the major cloud providers, sorry about that, the guest of honor almost didn't show up, but that's okay because, we miss him. All the major cloud providers, they give you these wonderful GUI-based tools. You can point and click, you can define your cloud-based resources, you can define the relationships between them, your whole cloud environment, but they're insufficient. They're going to lead you down some dark paths, and there's a better way. Here's that better way. We're talking config as code. You are going to write code to define your cloud environment, the resources, how they talk to each other, the whole thing, and there are some real good benefits to this, some great benefits. Not the least of which is, once you've typed out that code, that description of how you want your cloud environment to be, you are going to have a canonical record of what's supposed to be there. If changes are made, you know what the original plan was because you typed it all out. And you can enforce best practices. So you want secure computing, and I imagine if you're here, you want secure computing, well, two heads are better than one. It facilitates collaboration. If you pick up that mouse, you start pointing and clicking, how do you know you did it the right way? If you have a record of what you did, someone can audit that, or you can avoid anti-patterns, the GUIs. They encourage you to do some choices that you're not going to want to make. Much easier to avoid those bad choices if you're doing code. You'll see what I mean if you don't believe me. And redeployment. Maybe you have a production environment. You probably have a production environment, and if that's true, you need a staging environment. Sooner or later, you're going to have to fix something in that production environment, maybe do some upgrades, increase capacity, whatever, but how do you know your changes are going to work? Well, you take that code that you used to build your production environment, you build it somewhere else in a different project, in a different account, and then you make your changes there. You test them out. You make sure it doesn't blow up, make sure everything works, there's efficacy. And once you're satisfied, once you know it's fine, take those changes, apply them to production, and there you go. You've got some stability there. You know it's not going to blow up because you tested it. Try doing that with point and click. Now, before we move on, I want to address this image on screen here. Obviously, this man is Richard Pryor, but in this still, he's playing Gus Gorman, Superman's greatest frenemy. And if you watch the movies, if you know your lore there, you know Gus Gorman hacks infrastructure. So throughout this presentation, I've included images of 80s hackers from movies, pop culture, TV shows, all that. And I know they inspired a lot of us to be here, to be in this room today. Today they're going to inspire us for either learning how to do cloud computing securely, or they're going to inspire us to, exploit other people's mistakes, like Gus Gorman. And honestly, look, that Zack Snyder guy, he did the Snyder Cut. He gave us a 4-hour Super Friends movie. And where's Gus Gorman? I don't know, but he's here tonight, so he's going to inspire us. All right, so how do you do config as code? I'm not just going to tell you how to do it. I'm going to show you how to do it. And the first step in that journey is to figure out what software you can use, what software is available. Thankfully for us, all the major cloud providers, and here I'm only listing 3 of them. I realize Alibaba Cloud exists. If you use it, you're beautiful, but we're talking about the big 3 here, AWS, GCP, Azure. They all have config as code solutions that come with the CLI, with the command line interface program that they already give you. So if you're using AWS, you can use CloudFormation, GCP, you can use Deployment Manager, Azure has Resource Manager. They're all great, they all do the job, but they're lacking something really important in that none of them are multi-cloud, and I think you should want to be multi-cloud. If your enterprise is married to one of these providers, and that's pretty common, what happens when that provider starts charging more than you want to pay, or their pricing becomes non-competitive? What happens when one of the other providers comes up with a new tool or a new service that you want to use? You need some multi-cloud in your platform, and honestly, the new services are coming out. I think AWS probably published 3 or 4 of them while we've been talking here. Especially in the AI space, there's some exciting tools, toys you should be playing with. Don't be locked into one provider. Fortunately for us, there are config as code providers that are multi-cloud like you should be. There's Terraform, there's Ansible, there's Chef. In this presentation, we will have code samples, and if I go too quickly, don't worry about it. They're in my GitHub. You'll get the link at the end. We'll show you how to do certain things in Terraform, all the examples, but I'm not here to sell you on Terraform. I'm only here to sell you on config as code, on best practices, on security. Ansible works, Chef works. If there's a tool that can do this that you're already comfortable with, go ahead and do that. But today's there's going to be a lot of Terraform. Also, I'm not just telling you should be multi-cloud. This presentation is going to be multi-cloud. You're going to see examples in AWS and GCP. One of the things I hope you get from this presentation is the idea that a lot of the service offerings between the cloud providers, if you don't realize this already, a lot of those service offerings map one for one, and we'll demonstrate that here. But if you do want to port your entire environment from one cloud provider to another, if you have a config as code multi-cloud provider, you can certainly do that. You'll see that is not unreasonable. So I don't know the backgrounds of everybody here today. That's fine. Security's huge. Not everybody has the same skill set, and you might be telling yourself, hey, I don't know DevOps. I don't know how to learn that. It is more simple than you might think. And here's a basic command set. You learn these commands, you can get started, you can go. Terraform, not as hard as it looks. Terraform init, that is your first step into this much larger world. If you take your code base and you take your production environment, Terraform init will sync that up. Terraform is going to keep track of everything it built, and that's how you initialize it. It's going to look at the code, it's going to look at it in reality, and it's going to start tracking from there. Terraform plan. You've got your code. You're going to build things. You're going to delete things. You're going to change things. What's Terraform going to do for you? What is it going to do to you? Terraform plan is going to show you on your screen all those changes, additions, deletions, whatever, before you destroy yourself. Hopefully it warns you. Terraform apply, that, you want to render your code, you want to make that real, there you go. That's the command, not that hard. Terraform format. So there's a lot of arguments that people get into fairly regularly. One of the bigger ones is tabs versus spaces. I'm not going to take a position in that. I honestly think the real answer there is consistency. But Terraform format will format your code. It's going to make it readable consistently. Please make your code readable. Terraform destroy. So we used the example of a capture the flag exercise earlier. Let's say you're done with that CTF. Somebody won, it was a great time, but you don't want to keep paying for those resources. Terraform destroy is going to delete everything, save you some money, clean up after yourself. Terraform import, that's hero mode. So when you take a new job, especially in any kind of IT-related field, you are inheriting the mistakes and the tech debt of the person who sat in that chair before you. And if that person picked up that mouse and made a whole cloud environment that way, Terraform import is the path towards bringing that probably poorly built cloud environment into config as code. It's going to be meticulous. That's not easy, but that's the way. And finally, Terraform state list. Like I've been saying, Terraform will keep track of everything that it built, everything that it's tracking. If you want to see that, there you go. It's going to show you the list. And this is what we're going to build today. This is a data flow diagram for a sausage tracker. We're going to track all the sausage in the world. And here's that data. This is how it goes. You can build something much larger than this. This is just an example. If you could build something Fortune 500 scale, larger than I can even imagine, or smaller if it's a personal thing, you can do all that. Don't think that you're limited to something this scale. So that's sausage data. First thing we're going to do is we're going to import that data into a bucket. For those who might not be cloud aware, that's okay. You can think of a bucket as being more or less a file system that lives out in the cloud. You can store your files in it. There's directories, or if you want to call them folders, there's folders, and you can share those files and directories easily between different systems. And once the data gets imported in there, we have what I consider to be the heart of the system. We have a virtual machine. A lot of times people in the cloud call those instances. And I'm probably going to go back and forth, but this virtual machine or instance is going to import that data from the bucket. It's going to normalize it, and then it's not going to save it locally, at least not for very long, and you'll see why shortly. It's going to save that data in an external database server, also part of the environment, external to itself, but not external to your cloud. And once it becomes time to query that data, our sausage hacker, you can see her at the bottom of the screen here, she's much cooler than any of us. She and only she will access that virtual machine. She'll query that machine. That machine is going to be a go-between between the database server. She knows what's going on with sausage more than the rest of us. And now we're going to start building this environment by looking at that virtual machine or that instance. And we're going to build it with an autoscaler. An autoscaler, also called an autoscaling group, allows you to scale up or scale down a cluster. So if you want tens, thousands, I don't know how many you can afford, copies of the same virtual machine processing data, because maybe you have data spikes, an autoscaler will help you with that. If that kind of scaling appeals to you, then I'm going to ask you, please look into Kubernetes, look into Docker Swarm. That's more of a containerization thing, but autoscalers will do it too. That's not what we're using autoscalers for. Autoscalers are going to help us promote stability. Stability is not necessarily security, but it's definitely in the same arena there. So we're going to be using an autoscaler. It's going to help us out. A couple of things we're not going to do, and this relates directly to those anti-patterns that I mentioned. A lot of times when you are pointing and clicking, those GUIs, they want you to go down some dark paths, and we're going to avoid those paths, and we're going to do it with config as code, much easier. We're not going to be coerced, and specifically what I mean by that is we aren't going to be using default roles. If you are doing anything in a cloud environment, you are accessing an API, even if you don't realize it. If you're just looking at things, making changes, adding things, deleting things, whatever, it's all an API. Access to that API is conducted with identity and access management, or IAM, and IAM depends on roles. Your resources get assigned a role, you get assigned a role, or an identity, however you want to put that, and you will have access to certain parts of the API, not others. That default role, especially in GCP, the default roles are way too powerful. That's not principle of least privilege. That's a trap, and we're going to avoid that. Similarly, no remote access. We're going to make it nearly impossible for anyone outside this environment to access it. Again, our sausage hacker, she's the only person who should be accessing this system. We're going to make sure of it. And there's definitely some anti-patterns that we're going to be avoiding there. And finally, we mentioned it earlier, all of that sausage data is going to be saved to that database server that we built. You'll love it. So here is the first part of the autoscaler or the autoscaling group. This is some code for what I'm going to call a group manager in AWS. And the first thing I want to draw your attention to is that row of ones near the top of the screen. That's our capacity. How many copies of this machine do we want to run? Here, we are running one no more, no fewer at any given time. Maximum, minimum capacity, our desired capacity, all one. We don't really want to scale this up. We don't want to scale it down. That's not what we're doing here. We're not pretending to be, Kubernetes here. We're doing stability. And how are we doing stability? If you see in red letters, if you see EC2 there, we are telling the group manager, check on this machine. Do some health checks. Keep checking it up on it. If this machine ever becomes unhealthy, if it's non-responsive, delete it. Remove it from the universe and replace it with an identical copy that's going to keep on trucking, keep on going, processing our data. So if that machine becomes wedged, if it becomes inoperable, we're going to still keep tracking the sausage. And just to look ahead a little bit, that's why we have that external database server, because if this machine does become inoperable, we don't want to lose that sausage data. We want to keep tracking it. And here is a group manager for GCP. Again, multi-cloud. You got that really nice one-for-one mapping in service offerings. Now here we only have 2 ones in the configuration. We have a maximum and a minimum because we only want 1 copy of that machine running, no more, no fewer. Under those ones, you're going to see 60. That is the cooldown period. It was 300 in the last slide. Those numbers are kind of made up. Use what works for you. But we're trying to prevent a boot loop here. Those health checks are great, but so what? You bring up a virtual machine, it loads up, it's got a boot process. It needs to wake up. You don't want to do the health checks before it has its coffee. If you do that, it's going to fail the health checks during the boot up process, and then it's going to get killed. The next one's going to fail and get killed, and then you're in a really awful boot loop. That cooldown period, that's how we avoid it. Again, 300 seconds in the last one-for-one mapping. It's pretty great. So we've told the cloud how we want to run that machine, but we have not talked about what we want that machine to be like, what we want it to do. Here's a profile. Maybe you want to call it a template. Here's the AWS version. And I want to direct your attention there to that big, long hexadecimal ASCII representation number there. That's the image ID. AMIs, or machine images, if you don't already know, those are comparable to ISOs. So if you want to install your favorite Linux distro, you're going to need an ISO. And fortunately for us, those cloud providers, they've thought of this. They have machine images already there waiting for you to use them for probably what is your favorite Linux distribution. They probably have it in there already. That code number there, that is for Ubuntu 2204, which is what we're using. I'm not endorsing Ubuntu. They'll like a different Linux, go ahead. I'm not going to have that argument because they probably support it. They even support a lot of alternative OSs. So I don't know if you're in like Microsoft Windows or something, they'll support you. And you can see once we've decided what we're going to install from, we have a T2 micro. We have our machine class. This is a cheap machine class. We're talking cores, we're talking RAM. This is pretty cheap. We're not asking for a lot of resources. We don't want to pay for a lot of resources. If you want to do that, I don't know your computing needs. You want some GPUs, they'll sell you some GPUs. You want to mine your Monero or whatever. They'll help you out with that, or a lot of that AI stuff is really GPU intensive. But that's not what we're doing today. Today we're tracking sausage, and you can see under that we can load up an SSH public key, so we can access this machine via our SSH key. We keep the private one at home. And the next 80s hacker pop culture guy that we have here, and I think you knew to expect him, you have David Lightman here, and it's not an accident that he's next to the metadata options. So for those who might not know, the metadata service is an HTTP, not HTTPS. There's no TLS magic going on there. It's an HTTP endpoint that your cloud-based resources can query to get information about themselves or their environment. And it is actually a pretty great tool for computing, but it's got a dark side here. So specifically in AWS, you can query that metadata service for your session tokens. You take those session tokens, you plug them into your own computer, into your own CLI, and then that AWS cloud thinks you are that role. It thinks you're it thinks you're this virtual machine. So if you're David Lightman's, I don't know how he got access to your virtual machine, but he did that. He did a session hijacking. He talked to the metadata service. All of a sudden, AWS thinks he's Professor Falcon, and he's launching a global thermonuclear war. We don't want that. So, or if you are David Lightman, hey, look out for that. Play some tic-tac-toe. But here we have some metadata options, and the first one here, we are disabling that service entirely. It's not necessarily the most useful. Not necessarily the most functional way to do it, but it is pretty secure. But if that's not your bag, if you still need the metadata service and it's pretty useful, look what we have. We can disable, we can require tokens, we can put a hop limit on that. So I know there's a high-profile breach a few years back where someone, they abused a proxy that was running on an instance or a virtual machine, and they proxied themselves into the metadata service. Yeah, they got the tokens that way, but here we're putting a hop limit on that, we're disabling that, we're trying to do things the secure way. And when I talk about the danger of using that mouse, this is sort of what I mean. Try to find those metadata options in the GUI. That's not easy. That's not in the front. You can put best practices in code. You can cut and paste that a lot easier than you can ever find it in the GUI. It's hidden. Here, David Lightman's back for the profile for GCP, and again, this should look really familiar. We're setting the machine type. We're also saying, hey, we want Ubuntu 22.04, but there's other options there, and David Lightman is next to the network interface, and there's one thing you're not seeing here in that network interface, and that's a request for a public IP address. We don't want this thing to be on the internet. We only want it on our private network. That network interface code, you see, that's the local network, that's the local project, our local subnet. We don't want that on the internet. That's a really kind of deadly anti-pattern that the GUI is going to lead you down. The option to turn that off, to not request that public IP address, that's hidden in my opinion there, but we're avoiding that. We're not including that. We're not including those directives. We don't want that public IP address. Why would we? And similarly, the default service account or the default role assigned to these machines, that compute service account is it's really overpowered. That is the default configuration. There are escalation paths there. So if David Lightman gets access to that virtual machine, he can query the compute environment, get a lot of information about the machines that you're running, and in some cases, he can even launch his own machines in your account with GPUs or whatever. You don't want that, so we created a new service account just for this demo, the sausage user. That sausage user has some limited scopes. You see we're defining those scopes. You can think of scopes as slices of the API. Instead of the whole thing, we're giving the sausage user access to compute read-only, so we can query information about the environment, but we can't make any changes. There's no writing. And similarly, storage read-only. So we can access data from that bucket, we can read it, we can't write to it, we don't want to contaminate that sausage data, we want the sausage to be uncontaminated, we want it to be clean, and yeah, we're protecting it that way. Again, not the easiest thing to do in the GUI, but here, it's code. So we've created an instance, we've created a virtual machine, we told the cloud how to run it, but it's out of the box, it's fresh, it's pristine, and I like disk space, but I also like functionality. We need to configure that machine, and so we're going to use a cloud config or a cloud init script. And cloud init is a really great tool if you're installing from the machine images that the clouds give you. It's probably already installed there. It's a service that's going to run at boot time, and it is going to query the metadata from your cloud environment, and it's going to download a script that looks like this. There's a YAML-based instructional language there with a bunch of different directives, a bunch of different things you can do. This is only an example. You can do a lot more than this. But right here, the first thing we're doing is write files. We're creating a file. You can create files with any file you want, anywhere in the file system you want, any kind of permissions, ownership, whatever. You have a lot of flexibility there. And we have a boot command and a run command. The boot command starts earlier than the run command, but those are bash commands. So whatever commands you would type in to configure your machine, to set up those services, you can do it right there. A lot more that I'm not showing you, but yeah, so the autoscaler group, when it creates this machine, it runs this boot script, and then you start processing sausage data. But who can access this machine? Well, hopefully you and only you, or the sausage hacker. So here is an example of a firewall rule. Sometimes they're called ACLs, sometimes they're called security groups. It's all the same idea. You're limiting network traffic. So here's an example for AWS, and you can see 2 IP addresses listed there. I'm not necessarily saying they're my home IPs. Please don't hack me. But we are limiting access to that SSH service to those 2 IPs. Those 2 IPs are the only people in the whole world who can access that service. Again, it's a real kind of specific AWS anti-pattern there, and I think the GUI's gotten better in the last few years, but when you create a virtual machine with that mouse, it sort of wants you to open up that service to the whole world. You don't want to do that. If you do open up SSH to the whole world, you're going to get brute force attacks pretty quickly. No. Here we're limiting it, and you know, you can audit this a lot easier. I'm going to direct your attention also to that egress block. This egress block, admittedly, not the best way to do it, but if you want to do patch management, you need to download those Debian packages, those RPMs from a server. Real world, those cloud environments, they're just as dynamic as any other, and it's a little hard sometimes to predict what those IP addresses should be. So here we're opening it up to the whole world. This virtual machine can access the whole world. You see that row of zeros, we can access that, but if you want to be more secure than this, and you should probably want to be more secure than this, delete that egress block completely, and this machine will not be able to talk to the internet. There you go, almost an error gap, not quite, but all you have to do is delete some code. Here is a firewall rule for GCP, kind of the equivalent, but one big difference here, I'm going to draw your attention to the source range. That source range isn't mine, that's not my home. That belongs to the Google's identity-aware proxy, and if you don't know about that, it's almost magic. Your gcloud CLI, that command line interface that Google gives you, that GCP gives you, it is so feature rich, it's pretty amazing, and one of the best things that it does is that it has an SSH or SCP, SFTP, whatever you want to call it, has an SSH client built into it, which has a really killer feature that they added in that you can use the IAP, the Identity Aware Proxy. You log into GCP with your username, your password, hopefully your MFA, you authenticate that way, and then you've got what amounts to a VPN between you and your private network environment. No need for public IPs unless you need public IPs. I'm not going to debate whether or not it's the VPN. It doesn't matter. Your SSH packets are going to tunnel through Google's backplane. They're going to tunnel through HTTPS. So you've got the TLS security features on top of the SSH security features. You're encrypting your encryption. It's pretty crazy. It's great. And all you need to do to enable it, it's super easy. There you go. Just to open up TCP to that range there. So let's talk about exploitation, because this is CloudOps for red teamers, and maybe people did things the wrong way. If you remember that cloud init script, those directives that were YAML-based. Well, what if people put secrets in there? And I don't know why, but people love to put secrets in metadata. People like to put passwords in there. They like to put certificates in there. So if you're an attacker and if you get access to that cloud-based environment, if you did it the wrong way, AWS describe instances attribute, that's going to show you that cloud init script. And if there's a password in there, that's a certificate, guess what? They're yours. Similarly, if you're if you're in gcloud, if you're in GCP, gcloud compute instances describe is going to dump that metadata. So I don't know why people put passwords in tags. But they do, so you want to see those passwords, you want those passwords, there you go, not that hard. And if you remember David Lightman pretending to be Professor Falcon, if you want to pretend to be Professor Falcon, if you want to play those games, there you go. It's a simple curl command if you want to do a session hijacking attack. Hopefully they disabled it. We showed you how to disable it. But if if they didn't disable it, if they used the GUI, there you go, not that hard. Let's talk a little bit more about identity and access management, IAM, and we are going to restrict what parts of the API our users or our roles can access. And here's an example policy for AWS, and those policies have policy statements that have 3 elements to it. There's an action, an effect, and a resource. And in this first example, our action has one API call. It has list bucket, and that is essentially ls or dir, if you like Windows. We can list the contents of that bucket. So it's like a file system, and you can do an ls, and we're enabling that for the sausage user. We're enabling it because the effect is allow. You can very easily make that a deny if you want to explicitly prevent this user from listing those contents. I don't know why, but you could do that. And the resource, you're not going to see a wildcard in there. If you made that resource a star, we would be enabling the sausage user to list the contents of any bucket in the world, assuming that bucket let them do it. But that's not principle of least privilege. We're better than that. So we are going to limit the sausage user to being able to access the sausage bucket. Similarly, in the next example, get object. We are allowing get object for the sausage user, and I said I didn't like wildcards, but I think we have a more constructive use of wildcards here. You can see that ARN, and ARNs, you can think of them like URLs for AWS resources. We are only allowing that sausage user to download files that start with the word sausage and end with CSV. So if it starts with sausage and has the CSV extension, the sausage user can read it. If you are, for some reason, sharing this bucket with other applications, the sausage user won't know about it. The sausage user can only download files and can only download the sausage CSV files. That's all it needs to do, principle of least privilege. We love it. Finally, SSM. We're going to talk more about secrets in code and how we can avoid it, but yeah, the cloud providers give you SSM, which is part of KMS. It's a secrets management system. You can name a secret, like a password or a certificate, and then restrict who has access to that secret. And here we are giving access to the sausage secrets to the sausage user. So for the name secret, if that name starts with sausage, we can download it, but that's it. And here is kind of an equivalent for GCP, and so AWS does things a little bit reversed in the way that I look at things, in that AWS is more about assigning the permissions to the user. In GCP, you marry the permissions to the identity and then apply that to the resource. So in this case, again, we're talking about the secrets management system. We are pairing, in the policy statement in the first block there, we're pairing secret assessor and viewer, secret manager viewer. We're pairing that to the sausage user identity, putting them together and then applying that pairing to the secret itself in the resource block you see there. That secret already exists, but here we're just giving the sausage user access to that secret. You'll see in the policy statement there, it says members. We could put more people, more identities if we wanted in that list, but again, we want to limit it to the sausage user. So we talked about auto-scaling groups and how when that machine becomes unresponsive, when it comes time, when that machine dies, it's going to be replaced with an exact copy. So we don't want to store the sausage data on that local hard drive or hard drive equivalent. We want to store that sausage data somewhere safe. So we have defined a database server, a database instance to manage that data for us. And fortunately, we didn't use the mouse to do it. So we avoided some anti-patterns. Those anti-patterns include, we aren't going to use secrets in code. That's not for us. We're better than that. And we are not going to allow remote access. Again, the cloud providers, they want to sell you an IP address. We're not buying. And here is some code to create a database instance in AWS. And I called it an instance just like the virtual machine because it is an instance just like that virtual machine. It's a VM. I'm pretty sure it runs Linux. Unlike the other virtual machine, you don't get to admin this. You don't have to admin this. The cloud provider is going to administer it for you. The only service you have access to, because you can't SSH into it, the database service is the only service you have access to. And in this case, we're running Postgres 14x. You have other choices if you want to run MySQL, if you like that, if you like Oracle. It's all supported. And the instance class, because we have to tell them how much we're willing to pay for. We're doing a T3 micro this time. This is a little bit better than we were using before. Still not the greatest. You might have to scale that up for a real-world example. And I want to draw your attention to that line there. If you see that blue false, publicly accessible. We're not buying that IP address. And if you point and click and you create that database instance, that's hidden in the GUI. They want to sell you that IP address. We don't want a public IP address. Why would you want the internet to talk to your SQL? I don't know. That astounds me, but we're not going to do that. And that's a mistake. And the gentleman on screen here, this is a personal favorite of mine, Kerr Avon from Blake 7, the brains of a massive fraud. He ripped off the Federation banking system, and I personally think the way that he did that was through, this is my headcanon, I think he used publicly available IP addresses and secrets in code, but we're going to avoid that here. In case Anna Grant is in the audience. She's not going to bust us. And the name secret here is sausage.rds.password.prod, and you can see we are defining an administrative user for this database instance here at the bottom of the first block. The username is pSQL, and you don't see the password for that. That is by design. So that data block at the bottom, Terraform is going to act like an AWS client. It's going to act almost like your CLI. And when it comes time to evaluate this code, when Terraform sees that data block at the bottom, it's going to reach out to AWS as you, and it's going to say, hey, AWS, give me the sausage.rds.password.prod secret, and I'm going to store that in memory. And when it comes time to create this pSQL user, I'm going to take that pSQL user, I'm going to take that password from memory, and I'm going to use those as parameters to the call that creates a user, and I'm going to create that user, And when someone gets access to this code, maybe they log into my GitHub, doesn't matter, this is safe. And here is equivalent code, again, that one-for-one mapping, if you ever need to port from one cloud to another. Here is equivalent database instance code, Postgres 14x again for GCP. And again, you look at that IPv4 _ that's a little bit of a misnomer. This database instance, it still talks IPv4, because IPv4 forever, but no IPv6, or maybe it does. But we will not be claiming a public IP address here. We're setting that to false. We're not disabling IP, we're just not gonna be on the internet. And again, I think that's hidden in the GUI. Those are some hard clicks to make. And we are doing the same thing with the secrets management system because, again, one-for-one mapping, we're talking to GCP's SSM, GCP secret manager. We're having Terraform ask for the sausage dash, RDS dash password dash prod. The naming conventions are a little bit different, but there we go. We're getting it from the secrets management system. And at the bottom, you can see we're creating that admin user. Where's the password? Not on screen. So let's talk more about exploitation. So these secret management systems, there are commercial alternatives, and I'm not endorsing those. I'm not saying don't use them, but you've already paid for one. SSM is already out there, but if you are a red teamer and if you want to exploit other people's SSM, here's a way to get started. Log in. If you get access to their AWS SSM describe parameters, that's going to list out all the secrets in the secrets management system. If you want to start downloading those secrets, if you want to start viewing them one by one, AWS SSM get parameter and then the parameter name with decryption, it's going to show up in your console. Those are your secrets, those are your passwords, your certificates, and Google. Let's say you're using GCP, G-Cloud secrets list. It's the same thing. It's going to list all the secrets, and if you want that secret on your screen, simply G-Cloud secrets versions access latest, because the SSM in GCP, it does secrets versioning, but that latest one is usually the one they're using. There you go. That's how you view the secret. Go ahead, steal trillion credits from the banking system. In a fictional universe, I'm not advocating fraud. All right, so let's talk about buckets because we're talking about cloud security, and buckets are, people mess that up a lot, but we're going to be better than that. That bucket doesn't need to be made public. Those GUIs have gotten better about this. They kind of used to want you to create that bucket as public, and you'd have to go out of your way to not make it public, but we're not going to make it public, and we're going to restrict it even further. Here's some code to create and hopefully secure a bucket, and the first code block there, we are creating the sausage bucket. Buckets should be uniquely named, so I have the sausage bucket, you can't have it. So right after we create that bucket, we're applying the private ACL to it. This is in AWS. The alternative is to make it public. I don't know why you would want to do that. There are entire search engines there dedicated to scouring data in other people's public buckets. You don't want to be a part of that. So here we're making it private. But what happens when you work collaboratively and people make mistakes, I make mistakes. What happens if someone puts a really destructive ACL or a bad policy on top of that bucket? So even though it's private, they open it up to big chunks of the world. We can stop that before it even gets started. You see that row of truths there? Those, look, we are going to stop people from clicking on anything that's going to make that bucket public if they get access to your environment. We're going to stop them from doing even redundant Terraform that's going to make it public. We've stopped it. Those truths all represent checkboxes in the real world in that AWS API. I personally think those checkboxes are hard to find, but here they are right here. So if Bryce Lynch from Max Headroom, if he wants to help out Edison Carter go live and direct with your data, he's going to have to look somewhere else because you did it the right way. Or if you are Bryce Lynch and if you see someone else's environment, there you go. That's an escalation path. And Bryce is back because here we are in GCP, and we're creating a sausage bucket over there, and we are limiting access to that bucket to the sausage user. You can see a macro at the bottom. Reader. We are only giving reader access. That's why reader is in capital letters there at the bottom of the screen. We could give it owner access. That would allow the sausage user to write data to that bucket, but I don't want that. I don't want to write data. I don't want to pollute the sausage. Don't contaminate it. We're only going to be reading. So before we end here, let's talk about telemetry. And telemetry is, by that I mean logging, and you want to create a forensic trail. You want those APIs that are the kind of the essence of your cloud environment, right? Anything you do in that cloud environment, you're accessing that API. There are telemetry services that will create logs of that access. In AWS, you have CloudTrail, and GCP, you have logging, also called the Cloud Operations Suite. In Azure, it's Activity Log. They exist. What they do is they tell the cloud to start sending JSON formatted records of what happened somewhere where you can access it later. So that JSON usually includes a timestamp. It includes the identity of the person or entity who did the call. It lets you know what the call was. Lets you know, hopefully, it lets you know the IP address that the call came from, and what resource was acted upon. And if it's an error, hopefully you'll get some descriptive error information right there. It's all great, but you do have to set it up. And because in AWS it's CloudTrail, we call those directives to set up logging, we call those trails. Here is some Terraform code to create a trail, and we are sending those log messages to an S3 bucket. We're sending them into S3. Buckets are the easiest place to send them. You can send them into a bunch of different places, but here we're going to send them to S3 because it's easy. S3 is cheap, long-term storage. It's pretty great for that. And as a piece of advice here, if you are doing cloud, if you're doing this for real, you might want to send that data to a destination, maybe a bucket, maybe somewhere else. Send it to a destination in a different account. If you separate the data, if you separate it into different accounts, then and you can totally do that. Your attackers are going to have to compromise 2 accounts in order to obscure their forensic trail. You don't want them to be able to obscure their forensic trail. I think if you are that attacker, then look for the buckets. Here we have kind of the equivalent here in GCP logging. It's called a sink. So where do we want that? Where do we want those logs to go? Again, we're sending it to a bucket. We could send that, again, a number of different places. You want to send it to your SIM. You can send it to your SIM. You want to send it to a Postgres. You can send it to a Postgres push pull queue. I don't know what you're into, but if you look at that filter, GCP logging, I'm not going to debate whether or not it's a SIM, but it does handle a bunch of different types of logs, not just these API logs. So we need to filter for those API logs. We need to tell it to filter out only the API logs, and there we are. We're doing that. We're sending it to a bucket because it's an example. And let's talk about exploitation. And here on this slide, we have Kate Libby from the movie Hackers. And I know what some of you might be thinking. I told you we were going to have images of 80s pop culture hackers from movies and TV shows. And, well, she's from the 90s. But, if you're not doing logging, then you don't have a timestamp and you don't know when she's from. So let's say you are Kate Libby and you get into a cloud-based environment. One of the first things you're probably going to want to do is AWS CloudTrail list trails. You want to see if they're even doing logging. Or similarly, if you're in GCP, gcloud logging sinks list, go ahead and list out those sinks. You'll see the filters. You'll know if they're logging. And if they're not logging, well then you can go ahead and hack the planet, and you can invite Lord Nikon and the rest of them with you. And if you're on the red team, go ahead and lace up those rollerblades. You can come with them because they're not logging anything. You can have at it. So that's it. Here we are at the summary. If I can leave you with anything, config as code is a much better way to secure your environment. There are security mistakes that you will avoid, and if you're a red teamer, look for those security mistakes. They're there. That mouse is nothing but trouble. You want to avoid it if you're on the blue side. But if you're on the red side, then hey, it's nothing but trouble. Have at it. Watch out for those insecure settings. Really, there's a lot of anti-patterns in those GUIs. Don't do that. You can track your. Hey, no passwords in code. All right, so I promised if anybody's interested, if you like those examples, go to my GitHub. You will see cloud environments that are almost ready to be built. You can almost render them. You'd only have to make a few changes, but they're, I think, pretty decent examples. The examples of the environment that we showed you here, that's my GitHub. If I inspired you, if you want to become a CloudOps person, if you want to build your startup environment, your Uber for firewall rules, I'd love to hear about that. If you have questions, shoot them at me. The easiest way to contact me is probably publicly, social media, Twitter, Mastodon. There I am. I don't know how we're doing on time. I felt like I went pretty quick. Do we have time for questions? All right. Do we have questions? I was so clear. Yes. Okay. Thank you.